Get set. Welcome to Geometry, Lesson 3-4, our first proofs of our lives. And you might have heard people say, I have proven by blah, blah, blah. And the word proofs in English is not the word proof in math. In math, it's it's like the ultimate golden standard. And we're finally going to hit that. So today's date is January 7th, 2021. It's a very important date for you guys. It's your first proof. You will remember this date for the rest of your lives, 1/7/21. Oh my gosh, I forgot to do an objective today. Let me type one out really quick. This is what happens when I get back in the habit of trying to make notes from scratch. Our objective today is learn how to do a proof. It's super important. How do we actually do a proof? So again, I'm kind of regurgitating some of my own words from before. These are the 4 theorems that you have to have memorized. What I mean by memorize is make sure you know side, side, side is a way to prove that triangles are congruent. Side, angle, side, angle, side, angle, 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 side. In general, if you have 2 angles on a side in any order, that will always prove that triangles are congruent. The hardest one for me to memorize personally is this second one, side, angle, side, because I frequently get this mixed up with, I'm going to do the funny one, the donkey. This one does not work. Maybe write it down and cross it off. This doesn't work. If you have 2 sides in an angle, it has to be in a specific order. It has to be side, angle, side, because with angle, side, side, or what most mathematicians called side, side, angle, to make sure it's not a donkey, right? You can have 2 possibilities. And I showed you guys that with like 3-2's lesson. So let me go through the reasons. These are the things, these are the exact words that I want you to use when you're doing your proofs. Eventually, our proofs are going to say, here is a fact. Why is this fact true? And you have to have a reason behind every fact. And these are the reasons behind the facts. So given, whenever you say this word given, it means something specific. It means that the info is directly stated. So the info is stated. What I mean by that is sometimes in the proof, they won't just say prove this. They'll say, and they'll actually write out the words, given that, I don't know, maybe they say, this line segment AB is parallel to line segment DC. Instead of actually writing these little notes that say that they are parallel, maybe they'll tell you in words that that's true. So sometimes they'll tell you that just in words, or sometimes it'll be from the picture. From picture. If you see, how do we spell picture? Dear gosh, picture. If you see something from the picture, like this symbol here, that means angle DAB and angle BD or BCD, those 2 angles are congruent just by this notation of this double arc and double arc. And you can see down here, I have another double arc and double arc. So I can say I have given information that these angles are congruent just from the picture. So it's either from the words are from the picture. It's information that is given from the very beginning. And then the following things are a little bit more finite, like line segments are congruent to themselves. This is basically saying if I have a line, this line is the same length as itself, which is silly to say, but I can have two shapes from that line. Like for example, if I had a line with a triangle and a line that maybe turned into a square, I can say, hey, this square has this side length and this triangle has that side length, but this side length is equal to itself. So that's what it's trying to say. The line segments are congruent to themselves. And there is a more formal way of doing this, like the reflexive theorem or whatever. But just know that if I'm using the same line for 2 different shapes, that line is still the same length. It's a funny thing to say, like, why would you have to say that? That's a proof. You have to be very, very formal about the length. Okay, vertical angles. Vertical angles, my picture for you is, hey, if I have 2 lines or line segments and they cross, this angle up here is the same as that angle down there. That's all that's saying. And you've seen this before. Vertical angles are congruent. This angle and this angle are the same. And this can show up in a bunch of different forms. But just know this is a tool in your toolbox. If you see 2 lines cross, those 2 angles are congruent. And you can also say these 2 angles are congruent as well, but it doesn't matter what order you choose. The opposite ones are congruent. They are the same angle. And if at any point I'm not making sense, I'm doing a bad job translating, you need to raise your hand and ask a question, because this is as easy as I think I can make it, but maybe you can push me to be a better teacher and make it even easier. I'm trying to explain this as easy as I can. So linear pair angles are supplementary. This word here, linear pair, means that I have a pair of angles that are on a line, like line, pair. Like if I have a line, I cut it in half, these two are a pair of angles on a line, and guess what? They add up to what a line is, 180 degrees. These two angles, I'll say this is angle 1 and angle 2. Angle 1 plus angle 2 add up to 180 degrees. That's all this is trying to say. If I have a line that's separated into two different angles, those two angles add up to 180 degrees. That is the definition of supplementary. Yeah, Wyatt?
I was going to ask it. You just answered it though. I was going to ask, what supplementary is?
Exactly. Yeah. Supplementary, always think of this as 180 degrees. And it's not in this list because it's not in the homework, but the other word, complementary, this is a word that means 90 degrees. But you don't need to know that for today's lesson, just a little bit of good review. Corresponding parts of congruent triangles are congruent. Dear gosh, what a mouthful. This is probably the hardest thing on this list to understand what it means just by looking at it. Corresponding parts of congruent triangles are congruent. My geometry teacher loved this theorem because you could abbreviate it and call it something cool that only the elite geometry students would know. It's Cpctc. And I am totally okay if you don't like writing out all of these words. In fact, I'll probably just say Cpctc. This is a fancy way of saying, hey, if you have these two triangles and I tell you that they're congruent, so you just now know that, somehow you've done your proof, you're like almost done with your proof, and I tell you, hey, these two triangles are congruent, guess what? This part and this part are therefore the same. This angle and this angle are the same. Every part of those triangles is the same. This is a fancy way of saying, hey, the congruent triangles, all of their parts are congruent, because we've proven that they are congruent. We've assumed that they're congruent. Now all of their parts are also therefore congruent. Even though we haven't proved that this angle is equal to this angle, because we've now proven that the entire triangle is congruent to that triangle, everything within that triangle is congruent to one another. All right, corresponding angles on parallel lines are congruent. And the key word here is corresponding. There are a bunch of things that happens whenever you have a transversal line. Here's another one with a transversal line, but this is basically saying, hey, you have a parallel line. The word parallel, right? Parallel lines. If I cut that with a transversal, this is the line that cuts it, the transversal. Corresponding angles means, and I'm gonna have to zoom in here because I drew this too darn small. This angle and this angle are called corresponding angles. It's as if I shifted the angle down. There's no rotating or fancy things happening. It's literally a shift down, a translation. In fact, the way that you prove corresponding angles is by translating lines from here down to here. It's a really easy proof. Another pair of corresponding angles would be this green line and this green line. You just shifted the angle up, or maybe you shifted it down, but those two angles are corresponding angles. And guess what? Corresponding angles on parallel lines are congruent. So you need to know the difference between corresponding and all the other ones. There's a bunch of them that are spread out through this lesson. The only two that are important for you to remember are corresponding and this other one, alternate interior. This is how Khan Academy says it, so that's why I'm putting this translation on here. When a transversal crosses a parallel line, which we just talked about, here's some parallel lines, not perfect. I'm saying that they're parallel lines. That's given information. So these are parallel lines cut by another transversal. Alternate interior angles are the inside armpits of a Z, the letter Z. So check it out. These are alternate interior angles. These two angles are congruent. I mean, those two angles are congruent there, those two angles are congruent here, but why? The why here is because they're alternate interior angles. Yeah, Kira.
So if there was like on the two outside angles, would that be alternate exterior angles? Like the far sides, I don't know.
Yeah, so alternate exterior angles is another theorem. It comes up on Khan Academy eventually, but alternate exterior would be
Oh, so it's
Um,
not, because I was thinking of the one to the the left of the bottom one.
like this one,
Nope.
left of the bottom one. This one.
Yeah. So that
Yeah,
would
this is
not be alternate exterior angles.
That's alternate exterior as well. Yeah.
Okay.
And technically, even though it doesn't look like a Z, maybe I stretched out the Z, this angle right here and this angle right here are still technically alternate interior angles, even though it's weird because your Z looks like that. But this angle and this angle are still alternate interior angles. Okay, so this is everything. I think I went through like 5 different practice as if I was a student, trying to collect all of the definitions that they use. There might be more on this list, and if there are, I'll add them onto the list for next year. This is a brand new assignment this year. This was not an assignment last year, so I tried finding everything I could. Let's try doing our first proof. We're finally there. We have the tools in our toolbox. These are all of the reasons. I'm going to be teaching you the very famous, maybe infamous 2-column proof. It's a very standard way of writing proofs because it's easy. It's the same form over and over again. It's called 2 columns because it has 2 columns. This is how I'm going to set out this proof. I'm going to set out this proof by saying, here is my information. And with every piece of information, like a lawyer, you have to say, why is this information true? So you have to have a reason behind each piece of information. So let's start off with some really easy ones. Guess what? Angle DAB, so angle DAB is the same angle, it's congruent to angle BCD. Angle BCD. Why? What about this diagram immediately tells us that these 2 angles are congruent? What word can we choose from right here are we allowed to use to say that these 2 angles are congruent? It came from the picture. How do we say that? What is our reason, Kira?
Well, I think that one was a given because there's the picture of the little arcs that show that those angles are congruent.
Exactly. Given is our reason. Perfect. Let's go through all the other given information. I'm going to say my reason for my next one is given. What's something else that's given to us? Someone else, tell me. Yeah, what?
Would it be line segment DC is parallel to line segment AB?
Perfect. Those 2 line segments are given because these little symbols. Perfect. Is there anything else that's given to us? It doesn't. Oh, there is something that's not given to us, but something that we might be able to use. So I'm done with my given. Let me tell you this. The next thing that I want to analyze that's almost given to us, it's very transparent, is this one. Line segments are congruent to themselves. What do you think I'm going to state for my info? I'm going to say line segments, cannot spell segments, and let me scroll out so you can actually see the diagram, are congruent, I'm lazy, to themselves. Jade?
Line segment A to D and line segment C to B.
C to B. Those are equal to each other?
Parallel themselves.
They're parallel. Not quite. So we don't know that they're parallel because there's no symbol there that says they're parallel. And what I want to say here is that the lengths of segments, so line segments, the lengths are equal to each other. What line segments are equal to each other? And this one is really silly to say. Yeah, Esha?
Well, wouldn't it be line segment AB is equal to line segment DC?
Nope, you don't know that because it doesn't say anything along that line. There's a question from Kira.
Could you scroll back up to the definition of this? Could you explain that? I don't really understand that picture.
So this picture is saying if I'm using the same length for two different shapes, then that length is that length. That length is the same length. So another way of saying it is if that length, if I called it, let's call it AB. Did you know that line segment AB is equal to line segment BA? Did you know that? Isn't that
So-
crazy? Isn't that mind blowing? That's what this is saying. Ashley, you have another shot.
So line segment BD is equal to line segment DB.
There it is. So BD is equal to line
DB.
segment DB. Perfect. Yep. And you have to say this. I'll talk about why in a sec. You have to say this. You don't know why yet. If you're confused, that's a good thing because I haven't explained myself. So it's okay to be confused. I should resolve this at the very end. All right. So let me give you a roadmap of what we're trying to do. By the very end of this proof, you can write the very last line in the proof right now. Hopefully, I think I can write it down here. I'm going to write my conclusion. This little triangle dot thing, this means therefore. It's a cool way of saying therefore. After all of the things that I've learned, therefore I can make my conclusion. My conclusion, it's already written for me. I'm going to rewrite, maybe can I screenshot? Can I be fancy about this? I'm going to rewrite this line because that's the thing I was trying to prove. Therefore, I'll put the triangle dot in front of it again. Therefore, triangle DAB is equal to, or is congruent to triangle BCD. That is my final line. And I'm going to have to write a reason for it. One of the four possible, there's only four possibilities that you have. One of the four possibilities could be side, 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 angle, side, angle, 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 side. It has to be one of those four for the reasoning for this last line. And in fact, you can figure what that is or figure out what that is right now. What do we have so far? We have an angle. So it's not going to be side, side, side unless we randomly have three sides. I do have an angle. We just showed you a side. We're missing something though. We have a side and angle. Angle side is not one of three theorems. I need another side or another angle. Yeah, Charles.
We have another side.
Where?
BD and DB.
BD and DB. Oh yeah, so that's our first side, right?
I thought it would count as two because you said it.
Well, it's one for each triangle. I have this triangle up here with one side,
Oh, okay.
and this triangle down here with one side. So I have one side apiece, one angle apiece. I'm missing another side or another angle. What?
I think that we can find another angle using one of the proofs that we've learned.
You're correct. We're missing
So
an angle.
can I explain what my thinking is?
Yes.
So given that line segment AB is equivalent to line segment DC and
Equivalent. What do you mean equivalent? You mean parallel?
oh yeah, parallel. Yeah, sorry.
Okay.
And we also know that line segments are like equal to themselves, which is the line segment BD and DB. That's like a transversal going through parallel lines, so we can use like corresponding angles or like alternate interior angles.
Yeah, so I like how you said that. Let's go ahead and make it even clearer for those that can't see it. Let's go ahead and extend this line and extend this line. And also make a line so you can see this transversal. Only pay attention to the blue lines right now. Look at these blue lines, ignore the black lines. We have two parallel lines cut by that transversal. I want to say some of these angles are congruent to each other. Does anyone see how we could do that? So I'm pretty sure Wyatt is probably there since he's the one that did the information. Let me call someone else. Kira, try it.
I think it'd be like the angle. Well, it's the alternate interior angles of like BC kind of.
BC. That's the wait, what angle? Is it DBC? This one?
Yeah, that one. And then I guess like ADB. No, but those aren't. Are they? They are. Yeah.
Actually, not those are alternate interior angles if I was talking about these parallel lines right here. Those would be the inside armpits of the Z.
Oh, so it's the other ones, but I don't know what to call those. Like ABC. Does it matter?
ABC is this entire angle.
Oh. DAB. I don't know. I'll give it.
DAB is this one. Yeah,
Kinda.
why? Help us.
Would it be angle ABD on that B right there? And the other one would be angle, it's gonna be on that D one because it's an alternate interior, but I don't know how to say that angle.
Yeah, so I know you're talking about this angle. Yeah.
Yeah.
How do you say it? I'll give you some time.
Would it be BDC?
BDC. Perfect.
Okay.
We want to say that those two angles are congruent, and the reasoning, as Wyatt said, is alternate interior. They're the inside armpits of the Z. This is, wait, that's not alternate interior. There we go. Alternate interior, this inside armpits of the Z. That's called alternate interior. So let's write that in our proof. Our proof down here is going to say this angle ABD, angle ABD is congruent to that other angle down here, BDC, angle BDC. And if you're confused by the notation of how to do angles, my recommendation, if you have to write them, is practice. If you're just looking at it, look at the middle one. Look at the middle one. Angle B, you're really talking about something over there. Angle D, something over there. That'll help you a little bit, but still, it takes a bit of practice. Those two are congruent, and I have to copy down all of this. I'm going to be a little bit lazy, and I'm just going to say alternate interior angles. Interior angles. Cannot spell. Angles are congruent. That's my quick way of doing it. All right. So what we've used. Oh yeah. What?
Now can we go up and decide, now that we have like two angles, and decide which one we can use to in the conclusion?
Yeah, we're done. All we need to do is write something right here and we're done. And exactly. So I'll give everyone time to think. We have, check this out, an angle. This is an angle. We have a side. No, that's parallel. This is the side. There we go. And we have an angle. Check the order of them. Be careful. What theorem do we have? Do we have angle, angle, side, angle? What's going on here? What is our final theorem that we're going to be using here? Oh, question, Kira?
Yeah, like why did you even write down that DC is parallel to AB? Like it doesn't matter.
Because this, that's a great question. Why? So again, everyone make sure that you're understanding the question. The question is, why did we write down this line? Because we're only allowed to use alternate interior angles if you have parallel lines. If you haven't proven parallel lines, you are not allowed to use alternate interior. You're not allowed to use corresponding. Anything that depends on the fact that there are parallel lines, you're not allowed to say unless you've proven that there are parallel lines.
Okay.
Yeah, great question. All right, how many people have an answer? Is it angle side, angle, angle side? It's one of those two. You have a 50-50 shot of it. And check the order of what's happening here. Go dun, dun, dun. What's going on? Charles?
Would it be angle, angle, side?
It is indeed angle, angle side.
So I have a
down here.
question as well. Like,
Okay.
what direction do you go in to do it? Like, I saw what you did there, and that's why I got my answer, but I'm still not really sure. Like,
So,
I would still think this would be like angle, side, angle.
okay, so let's look at only one of the triangles. You want to look at the top or the bottom triangle?
Let's go bottom.
bottom. So we're looking at triangle DCB. If I'm looking at this bottom triangle, everyone try to maybe hold your thumb over the screen or something. Ignore this top triangle. Charles, I want you to pick anything that you want to start with. You want to
Let's go
choose
with an
angle.
angle D, I guess. The
So if you start with
BDC.
angle D, so if you start with angle D, there are only two things that are right next to angle D. There's angle C, and then there's this side, but you can't jump all the way over here. You can't jump all the way over here because that's a side and an angle that you would be bypassing. So you actually can't start with angle D. You have to either start with this side or this angle, because otherwise, if you start with angle D, you'd have to go angle D, angle C, oh, skip this other angle, and then over to the side. You're not allowed to skip both an entire side and an entire angle.
Okay, that makes sense.
Yeah, question what?
So then couldn't it also be side angle angle?
Yes, it is. It is. Yes. So this is the same thing as side angle angle. It doesn't matter. Most people say angle angle side because the alphabet A is before S, but these are the same theorem. It doesn't matter. If you say side angle angle, I'm not going to take off points. Khan Academy only gives angle angle side as a drop down option to click on. But yes, you're right. They're both the same. And the one thing that I want to say, I ran out of way too much time. But the one thing that I want to say here too is I am only allowed to write down an angle if this A came from some line of the proof. And this is the reason I would need to circle back, because I promised, why did we write down this? This is so silly. In order to write down S, you have to have those sides somewhere in your proof. You have to have somewhere saying that this side of this triangle is equal to this side of this triangle. If you've never said that in your proof, you are not ever allowed to say, hey, well, the sides are congruent. If I saw that proof, I would say, what sides are congruent? You haven't even talked about any sides. You have to talk about that side somewhere before. And then here is the cool thing that we get to do at the very end. If you want to be super cool and hip, you say this little black box that's filled in. This is a way of saying, I have proven it. I am done. Check it out. We're done. If you want to say boom shakalaka, you can say that too. Another formal way of saying it, the most formal way that I've seen doing it, is QED, quorum et deternum. It's the Latin thing of saying, I have proved what I set out to do. Yeah, Kira.
I still don't really get why it matters the angle, the order of like AAS or ASA or SAA.
Okay, so it does matter, but it doesn't matter if you're going clockwise or counterclockwise. The only rule is don't skip both an entire angle and an entire side. So notice that this is an angle that we never use. This is a side that we never use. This is a side that we never use. Those are the three things that we never use on that triangle DCB, that bottom triangle. I'm not allowed to skip both an angle and a side. I'm not allowed to jump over here. I'm not allowed to go through that with my proof. So if I want to say side, angle, angle, that's fine. I cannot say angle, side, and then skip over this giant angle inside to come back here to say angle again. Angle, side, angle, this doesn't make sense. I'm going with things that are right next to each other. These two angles are right next to each other, and then that's right next to a side.
Oh,
So
when
go for it again here.
is that angle like by the C?
Say that one more time.
Like the angle that's right next to this letter C, when did we use that? Why do you need it? Like
This angle right here.
Yeah.
We said that at the very beginning. That was given information, and we
Okay.
need an angle to have angle side.
I see.
Question, Charles?
So then you can skip over like one angle or one side, but you can't skip over two or more.
Yeah, you can't skip over both an angle and a side. The reason that you're allowed to skip over a side is because you're saying that this angle is neighbors with this angle. So of course, if this side had somehow been used, then I wouldn't skip over it. But I mean, the logic here is as making sense as possible. If I have a theorem that says angle, angle, side, these two angles must be right next to each other. And then the immediate thing right after this angle must be touching the side. So these things have to be as close together as possible. Okay, we get out of here at 10, right? We do. We're gonna pick up this lesson tomorrow. The homework is online if you want to try doing some proofs on your own. If you do the homework tonight, that's awesome. You're going above and beyond. I'm going to make you do it again if you do it though, because you really need the practice. So I do recommend doing the homework twice. Proofs are hard. I know that. It's the reason I didn't like them when I was in high school and in college. By the way, we're doing baby level proofs. Like full on level proofs are way more fun and a lot harder too. So tomorrow we're going to do example 2 and 3, and then we're going to work on the homework. But I highly suggest at least trying 1 or 2 problems on the homework tonight, if not all of them. So we have exactly 1 minute left. Are there any questions that I can answer before we move on to the lesson tomorrow and finish this up? Okay, I need a general fist of 5. How well did you follow all of this convoluted nonsense of how do you do reasons, and also the first proof that we've done? Oh, okay. 5, 5, 3, 4, 3, 3. I didn't lose anyone. No one was at a 2 or less. Okay, that's awesome. So yeah, that's what we're going to do tomorrow. I kind of want to show you one of my, I have a lot of favorite proofs. I want to show you one of a cool written proof with words. You can do a proof, by the way, with pictures. There's a bunch of different ways to do proofs. I'm showing you the one that you can use over and over again, but really there's an endless limit to how, maybe not, almost an endless limit to how you can do proofs. So with that, I'll stop the